Hello, this is Jeremy Hogg from Hogg's Electronics. This is a video that is part of a series on the Analog Discovery Pro 5000 series. The one behind me here is the Analog Discovery Pro 5470. This is a 350 megahertz MSO and all-in-one combo. Legal disclaimers: the opinions expressed in this video are my own and not of my employer, university, and that even of Hogg's Electronics. These are all my own views as an individual. Once again, this unit was provided by Digilent. They are sponsoring this video series. Alright, so now let's get to unboxing this product. So I'm going to try to do this one-handed with the camera like this and with my Leatherman. As you can see, I still haven't really invested in actual camera gear, but that's fine. We can make this work. And so when you unbox this, we are greeted with probably like a quick start guide. What's that? Yeah. Oh yeah, the overview of the instrument. So yeah, again, this is quite a powerful instrument where I was talking with some folks about this, not this product in particular because I wasn't allowed to talk about it, but in general with instruments where right, you buy a scope or like a spectrum analyzer or something, right? And then literally, right, you have to buy all the software options for like decode or demod, whatever options to make the instrument useful to your needs. And okay, so now we got safety information, environmental, okay, important. But anyways, yes. So yeah, that right. I kind of call it, right, test equipment DLC, basically, right? Because that's basically what it is you pay for the software keys or options to unlock some of these features. But in this case, for around $4,000, you get all these options unlocked out of the box, basically, is how I would think of it. Because, right, it's very easy when, again, I'm going to approach this review from three different perspectives. Because again, I'm kind of in the unique position right now of being fully employed somewhere as an engineer where I use a lot of these instruments on a daily basis, and then I do hobby stuff with ham radio and just general electronics tinkering, and then as well as also being currently a graduate student. So I'm going to try to approach this instrument from all three perspectives of, right, education and research to then where would this be placed, or would I recommend this for a job, or then of course this is kind of a stretch in my opinion, but I think it's still worthwhile to see what the applications could be for a hobbyist. The price is a little steep, I will say. I'll get into that a little later, but when you think about it, it's not that much more than if you bought like a new modern scope or something these days. And so yeah, let's continue on. So again, walk around, I guess is what they call this, yeah. And then and then the quick start, which is again, I love the waveform software. That is something I'm very used to after all these years. It is in my opinion one of the defining aspects of just really in a strong pull point for all the analog discovery products from Digilent. Just that software suite for not only their analog discovery, but their digital discovery and and I think even some of their FPGA boards support it now, which is kind of crazy. It's a very, very powerful instrument suite with basically there's no software unlocks needed, no keys you have to buy, right? No additional DLC, basically, right? You get it all included out of the box. So, put that aside. And now we got, what do we have here? The accessories box, which, let's see. So we got, multimeter probes, nice big ribbon cable, a Digilent screwdriver, yep. I don't know where I placed one of those from a while ago. I don't know if the scope probes are in here. Okay, we got power cords. Okay, yep, so we'll put that aside for now. Over here. And then, oh, okay, so yeah, I got 2 accessories boxes here, because again, this is a very big box. Big instrument, requires a big box, requires lots of accessories, so. Okay, so yeah, I think this is they gave us the 500 megahertz probe, so that's actually a very good thing, because, right, you want to, based on the model, right, which is this 350 megahertz scope, you want to have scope probes that are a little bit over that, because, right, again, what most people don't realize is, let me focus on this. Yeah, there you go, 500 megahertz. The one thing that even I fell into for a while, because, right, before I learned most of the RF stuff properly, yeah, you would think that, do I buy a 100 megahertz scope probe for my 100 megahertz scope? The answer is no. You actually kind of want to be a little bit over that, so like you probably want to double, or like was either times 0.5, so 150 megahertz or 200 megahertz probes you would probably want to buy, just so that you extend that 3 dB point a little bit further, because, right, the instrument's front end is already rated at 3 dB, 100 megahertz, so you're already losing about half your power, and then you lose another half through the probe if you're right at that number. So typically you want to have scope probes that are just a little bit further out. So in this case, right, 500 megahertz for a 350 megahertz scope. I actually do wonder what scope probes they bundle with the, because again, I only see them 300, 400, 500, so I don't know. I'll have to ask them, or at least look it up later. But yeah, okay, now we have just the instrument, and it's good to see that this is properly packed with this nice packing foam that's, I don't know, it's like molded or welded in this shape. So let's see, let's try this one-handed. Alright, and camera. And yep, there we go. And yep, there we go. We have our ADP Analog Discovery Pro 5470. And wow, that is quite impressive. And then, yeah, we got digital I/O, we got the 1 gigasample logic analyzer, and yep, here's the 4-channel mixed signal scope, or yeah, just the scope. And then you got your arbitrary waveform generator, and your trigger, and then your multimeter. Yeah, that looks fan-freaking-tastic. I'm very excited to boot this thing up. Alright, so let's... Oh, nice and askew there. There you go. Alright, now on to actually powering this thing up. Alright, now we got this powered on, and we got USB connected. And yep, we got the waveform software installed, and that's all up and running. I'm going to try, again, this is just kind of like an initial unboxing and, I don't know, basic functionality testing, so I'm going to try out the multimeter with my new DMM Check Plus I got literally yesterday, which is kind of good timing. And then we'll just try one of the scope channels, and then, I don't know, we'll just like kind of do some other basic measurements to just check out this instrument. Give it a nice little minor test drive. So let's see, we got DMM, and okay, interesting. This is first time I've ever seen the interface. And okay, yeah, so we got resistance, continuity, diode, DC voltage, AC voltage, load current mode, so I get milliamps, and then what's this? Oh, and then it's AC low current, also milliamps range, and then DC high current in the amps range, and AC high current. Let's see. Oh, interesting. So, that is quite interesting. If I could focus this. So you can switch between 10 megohm and 10 gigohm, which is, that's different. Because right, ideally, right, when you model, or at least when you learn circuits on modeling like the multimeter, at least when you're initially learning what effect that has on your measurement, you assume that ideally that your multimeter is like infinite impedance, or at least really high. And yeah, traditionally, yeah, they're usually close to like 10 megohm, but wow, 10 gigohm, that's like practically open. I wonder how they did that. Because that would like barely load the circuit down. So I'll have to see if I can measure some like really high resistor values here. I might have to consider that in my test plan, so to speak. And nice thing is that they have the trend plot basically just right there. So I'm thinking like if the Fluke software out of the box was pretty easy to use, I would imagine like this. Yeah, so let's start running this. So let's see. Oh wow. Okay, and then it auto scales. I'm gonna turn on this. This is on DC mode. Okay. We're gonna measure. Oh, this is fun. I have to measure with one hand. So let's do. Oops. Swap the camera here. Voltage out, and it should be around 5 volts. And wow, look at that. That's basically 5 volts. I'm an engineer. I like to round up. That to me is 5 volts. And let's measure the battery voltage, which this should probably vary a bit. Let's see. Yep, so we're measuring that. And there's a fresh 9-volt battery there from the factory, so that should be pretty close or above. Yep, it is. It's good to see that. All right, now, what else can we measure in here? Okay, let's measure some of these resistors. So we can turn this off. Let's see. I don't really feel like measuring current right now. Oh, hello. Oh, okay. Software crashed, so I am thinking that's probably just a bug, maybe. I'll have to report that. Let's see. Okay, yeah, there we go. Run. Okay, open load. Let's try this again. Oh, hello. So measuring 100 ohms, I think. Oh wait, does this have to be on? No? Hello? Why no worky? That's not good. Okay, but there might be a problem with this version of the software, potentially. It's running. Okay, come on, run. Or did I actually not press run? Okay, weird. Now I see the plot updating. So yeah, we'll return to measuring one-handed. Oh yeah, there you go. There's 100 ohms. Yeah, 0.1003 k ohms. So it's okay. That's acceptable. Okay. Now we got 1 kilo ohm. It's 10 kilo ohms. It's 100K. Well, it's like perfect on the first try there. All right, that's cool. Let's see. So no capacitance measurement mode on this instrument. That's fine. I mean, they have the impedance measurement tool on here, which is in itself one of my favorite features of all analog discoveries with the waveform generator is being able to measure impedances. And let's see. Okay, I'm a little scared to do this without anything in series. Okay, interesting. Did you just see that? That instrument like momentarily disconnected. Okay. So allegedly, this should put out a current, a low current. So let's try this. I'm a little afraid to do this on a new instrument. Oh, there you go. There's 1 milliamp basically. All right, okay. So that works. Now I have nothing to be afraid of there. The reason why I say that is because, right, the first thing that I didn't run into this problem in Circuits 1, but Circuits 1, especially for me when I was basically a lab assistant for all the labs, maintaining all the equipment, first week, without fail, almost every multimeter out of the lab, the fuses would be broken because all the students would measure current in parallel mode. You're not supposed to do that. You're supposed to measure in series, so they just create a short circuit because right, that's what the multimeter is when you're measuring current. Is that it's a short because right, it's basically a shunt that's near 0 ohm, and yeah, without fail, almost every multimeter would come back with all the fuses blown, and that was always the ritual, was to replace all of them. And again, yeah, that's why I'm like very hesitant to just immediately measure something technically in parallel there. So yeah, that works, and glad I have this. That worked, and yep. So interestingly enough, I think they still have some problems to fix in the software. Let's try a scope. Yep, and yep, all channels enabled. That's used to that. All right, let's plug in channel 1. Yep, so let's do that, and then let's measure that square wave that's coming off. Yes, that is not perfectly the square wave because we have to compensate the probe if. Oh, there it is. Okay. Yep. So I think this accessory kit came with. Yep, it did. With the non-loading screwdriver, meaning that okay, non-loading / non-conductive screwdrivers, right? If I use the metal screwdriver, it would conduct into that variable capacitor, and then tuning this would be really difficult because basically I become part of the circuit, but because this is insulated, right? It's just plastic basically. Let's see, let's try. Oh, so yep, you don't want that. Let's try. There you go. Ah, perfect. Okay, now this probe is properly compensated. And do they actually post the? Nope, they don't tell you what waveform it is. Not to be too nitpicky, but usually most test equipment manufacturers will put what this frequency and output is, unless, I don't know, maybe that's like lab 1 of, or maybe lab 2 of using an oscilloscope is, hey, figure out what the ratings are for, or what the output of this is. Yeah, find that waveform. Don't use auto scale. Yep, so okay, that's locked in. Alright, now I'm kind of curious to see, how do you set 50 ohm? Oh, there it is. Oh, okay, that's good to see. So you could actually do, what I'm really excited about this is for ham radio stuff, because again, this is like perfectly in the frequency range of ham radio stuff up to VHF. Yeah, it's like the 50 ohm mode starts to really matter. So yep, that looks all good. Let's see. I'm used to my nice measurements here. Alright, so if I double click this, that gets added. Do vertical, peak to peak, minimum, max. Alright, yep, that's what I like to see. Yep, and is there any filtering we can add? Oh yeah, there's AC coupling, so that brings it down there. We got 20 megahertz band with limit. That's all good. Okay. What other fun stuff do they add? Okay, this looks all pretty standard. Okay. Okay, I mean, yeah, that's pretty much what I'm used to as far as any analog discovery product. Yep, so that seems to work. And let's see. What else is there to talk about now? Oh, actually, let's try an eye. Oh, nice. That I have not really seen in the waveform software at all, is the eye diagram analysis, which is basically overlays all these acquisitions. All right, let's do FFT. Oh yeah, there we go. Oh yeah, let me see all those harmonics. Oh yeah. Let's see what happens. What time scale does this put me at if I go to 1 gigasample, 1.5? Oh, okay. Oh, okay. Oh, okay, so interesting. 1 microsecond is, I guess, where you could set it to the max rate, and then anything, whoops, focus. Thing above that, you start to have your sampling rate, which is pretty standard. Okay, good to know that. Spectrogram. Oh yeah, okay, that's what I expected. Again, you don't have to pay. I mean, not that FFTs are paid for anymore. I mean, that used to be the case apparently for a lot of instruments in the early 2000s. But yep, again, that used to be like DLC at one point. And let's see, what supplies look like on this. Oh, nice. Okay, so I wonder. Let's see here. Okay, yeah, we can current limit. That's always good to see. I think that's pretty standard. Yeah, same case with the 6-volt power supply. I am glad by default those are all pretty low, but pretty standard. Oh, okay, so they enable tracking so that these follow each other. Actually, that makes me wonder if you had the plus minus, let's see. Yeah, I guess what I'm trying to think is, okay, so if you reference this side, actually, is this ground? I imagine so, I guess common, but so I wonder if you measure across this, if you get the full 50 volts. Well, I guess one way to figure that out, or find out, is run the multimeter, right? We got a multimeter. Let's see. So let's set this up to 25. Set this up there. Actually, let me double check. Okay, so we can measure up to 300 volts. We're fine. Okay, we're not in any danger of running into the limit. All right, let's do this. Whoops. Oh no. Let's see. Oh, yeah, okay. Annoying thing with this. Oh, whoops. Let's switch that back to volts. Fortunately, I was not plugged into the amps mode there, or the ammeter. So now we're measuring across the positive and the negative output, and oh wow, there we go, 50 volts. Okay, so I was right. So yep, this is indeed a true dual rail supply, and you can, in a pinch, get up to 50 volts if you need to. Just that's good. Love to see it. Okay, now we turn that off. Okay, let's turn that off. And yeah, again, nice to see the trend plot with the current and voltage there. Let's see. What else is there? Let's look at how network is. Okay, that's still the same. Impedance, that's the same. Logic's the same interface. Did data logger look like that? I guess it did, maybe. And WaveGen. Yep, which is the same one. Scripting. Okay, so as far as that, if you guys are used to the other analog discovery products, should be a nice transition. Let's see. Yep, so I got the GoPro. Put that back here. Yep, so. Well, yeah, my initial impressions of this instrument is, yeah, this thing is solid. Not all plastic. I think this is like metal on top and then plastic on the sides. So it's a very well built instrument. I'm trying to remember because my initial research when they told me that they were going to make this product or they were going to announce it was, I think this is maybe potentially a rebadge of a National Instruments product from a while back, like the NI, what is it? I'll probably post this later, but yeah, like I mean, I would much prefer, like in a lab setting, if these were like the all-in-one solution that my school used, that'd be perfectly adequate. I've seen a lot of schools move to like an all Rigol setup or some of the lower test equipment brands, and that's adequate. Again, it's a very competitive test equipment market. That's what I'm going to try to go into with one of my reviews. Is that it's interesting given the context that with some of the products that Rigol and Digilent have put out, very high performance products, very good value for the price. Again, this is only an 8-bit scope, whereas now we have 12-bit scopes on the market that are in the hundreds of dollars range. And I don't know, that might be a make or break it point for some people, or a deal breaker for some people. Again, right, this instrument caters to I don't want to say like maybe like a broad to like a very specific range of people. Like for me, this is great for. I already know like a few use cases, and hopefully I can share those. And I don't know, maybe some schools will watch my video, some lab managers, and then or professors. But hopefully they'll agree with me because again, this is very slick. Again, with the very nice waveforms UI that I'm at least very used to, and I love the scripting in it too. Right, like that to me is very intuitive, and yeah, that's always been very like again, this is like home for me. Yep. So that at least concludes my initial impressions of the ADP5470 by Digilent. It's again, I think it's pretty impressive. I kind of want one. I get to keep this one, but different case. Again, I'm gonna try to be as unbiased as I can because again, I know how right. I'm approaching this from 3 different perspectives, and of course, right, any instrument's gonna have its compromises and such. But I don't know. I mean, this seems pretty full featured for some stuff. I mean, right, you're always going to want something else. And then, right, it's always, with higher end test equipment, it's always easy to I mean, right, you get that sticker shock upon seeing it. But then when you realize the other players in the market and what it takes to get a configuration that's similar to this, as far as just the MSO, yeah, I mean, that alone, right, that not too long ago was pretty pricey. And even now, that's still pricey. And plus, right, let's not forget that, right, the small form factor, so again, it's all in one, and it's surprisingly good. And again, right, like as of right now, out of box at this very time on launch, software is a bit buggy here and there. Again, the multimeter function definitely crashed on me at least once, and then had a weird disconnect moment, USB disconnect event. Uh, so I mean, all stuff that'll probably be polished up. I expect nothing less from Digilent. And yeah, so that concludes my initial impressions video. Thank you for watching.